Hey Marlena, the first thing I'll say about this problem is you will never, ever, ever get anything anywhere near this difficult on the SAT. So I'm surprised that Khan Academy is being this wacko with the genre of questions that they will ask you about, but nowhere near this difficult. So let's look at what we have in this problem, and then I'll give you a simpler example of a problem that they could ask you. But this is way off base. Those are our initial equations that they were given, that we were given, and we were told no solutions. No solutions to a system of equations means we have parallel lines, and that means that the slopes have to be the same. So that's what we're looking for. We're looking to establish what value of C makes the slopes the same. But I can't reinforce enough the fact that this is a nutty problem because it's way harder than what the SAT will ask you about. Okay, so this equation here we can solve for A, and then we get it into the form of y equals mx plus b. So let's do that. And you can see here where I've already done some work. I took the first equation, this one here, and I did some distribution, and I distributed it again to get to this point. And I took this equation here, and I distributed inside the parenthesis to get to this point. Well, I want to work with equation 2, that's to say this equation, so that I can solve it in the sense of, y equals a and x equals b. So I'm going to solve for a, and then I'll have it, I'm going to think of it in terms of y equals mx plus b. So taking this equation and solving for a, I'm going to add 1.5a to both sides, and I'm going to get 1.5a. I'm going to add the negative 0.2 to both sides, and I'm going to get equals negative 2.5b plus 0.2. I'm going to divide by 1.5, and I'm going to get a equals, when I divide by 1.5, I mean, this is just, the math is messy. The whole thing is just a total mess and totally inconsistent with the way the SAT would present a problem like this. And I'm going to get 0.2 divided by 1.5, which is, boy, I don't know, it's whatever. Let's see, I have that somewhere. Well, I think I actually messed something up here. It doesn't really matter what the I have written down. This number doesn't matter so much. I've written down that it's 32 over 15. Because I made a little mistake in here. But this doesn't matter. What we're really interested in is making the slopes the same. So now I have something in the form, and I think you can appreciate this, of y equals m x, that's my x, plus b. What I'm really interested in is that the slopes are the same. If I look at the second equation, that's to say, well, the first equation, this one up here, and I simplify that, that gets me down to this here, where I get 6 equals 1.5a plus 1.5 BC plus 1.2 C. And if I want to start getting A by itself, I'm going to move this crud over to the other side, and I'm going to get 1.5A equals negative 1.2C minus 1.5 BC plus 6. What I really want to do is get A by itself there, so I'm going to divide by 1.5, and I'm going to get A equals, and again, I mean, the numbers are terrible here. The whole thing is not indicative. But I'm going to get A equals negative BC. That's by taking this term and dividing it by 1.5, which is that. So I get A equals negative BC minus 1.2C over 1.5. I'm just showing you how ridiculous this whole thing is. And 6 divided by 1.5 is 4. The only thing we care about is that this term that has B in it, and we're really associating B with C with X, is the same as this. So we want C to be equal to negative 5/3. Well, we want, because there's a negative sign here and there's a negative sign there, we want C to be equal to 5/3. And that's our answer. C equals 5/3. I can't stress how insane this was in terms of its difficulty level versus a regular SAT question. So what I'm going to do is I'm going to send you another video with something that's more comparable to the type of question that the SAT would actually ask you about the same type of problem. All right, Marlena, that is that. I'm stopping, and I'll send this, and I'll send you another video in a second.